Hi everyone, welcome to today's tutorial. So we're solving question 4 from your tutorial sheet, and this is just an introduction to logarithms. So if you have not yet subscribed to the channel, make sure that you do so by clicking the button down there which says subscribe, and then also hit the notification button so that you don't miss out the videos I'll be posting. And then if you have questions, feel free to contact me on any of these lines. Okay, so we have this question here on logarithms. Given that y is equal to log x base 3, find expressions in terms of y for log x and then over 9. So the first thing that you need to understand is that when you have two functions dividing themselves, or when you have two functions dividing in logarithms, that is just the same as subtraction. And then when two functions are multiplying, it's just the same as addition. So what I mean is this: if you have, let's say for instance, log a over b, then base, I'll just say base c. So this one is just the same as log a base c minus log b base c. Then if you have log a times b base c, this is just the same as log a plus log b. Of course, they all have the bases c. The other thing you need to understand is that any logarithm that has no base is simply just in base 10. So this one is just in base 10. And then we also have a special logarithm called a ln function. So this one, when you have ln a is simply just the same as log a with the base e. So e is simply just an exponential. This is just a constant, it's a number. And the calculator is something like 2.7 something going up. So that is ln. Okay. So the other rule that is very important on logarithm, I think, is just changing a log function into an exponential function. So if you have, for instance, you have log x base a, then this is equal to y. You've been taught to convert this to exponential. The base will remain a base, so a base will be a base, and then this is going to be equal to x, and then what you have this side becomes a power. Yeah, so this is what it means. This is how you convert this a logarithmic function into an exponential function. The other thing that is, I think, more important is converting from one log to another. So if you have a log, let's say log 5 base 2, you want to convert this to base 6. Well, this is just going to be equal to, so this is just going to be equal to log 5 and then over log 2, log 5 over log 2. Then you, if you are converting it to base 6, you put 6 there. If you are converting it to base 10, you leave it like that, or you put 10 there and 10 there. If you are converting it to base 2 or base 3, sorry, you put 3's there. That's what it means. And then the most important one that you need to know on this one, that is going to help us to solve these questions, is that if you have a log of a and a base a, this one is always 1. What this means is that if you have log 2 base 2, the answer is 1. If you have log 3 base 3, the answer is 1. And then the other thing you need to know is that log of 10, the answer is also 1. Why do we say that? Because the base is 10 there. Yeah, so we can see that it's in this format. Same applies to the ln of e. The ln of e is equal to 1. Why do we say that? Because we know that ln is simply just a logarithm, a special logarithm with a base e. So this one can be written as log e base e, which is also 1 because it's in that format. And then the other thing is that log 1 is equal to 0. This is what you should understand. Alright, so let's quickly begin to solve the logs. So we have this question: given that y is equal to log x base 3, find expressions in terms of y for x, for this one. So we have log x over 9 base 3. So this one is simply just going to be equal to log x base 3, then minus log, I started with this rule, so minus log 9 base 3. So this one is an equal sign, then we have a minus there. Since we are dividing here, meaning we have to subtract there. Then log x base 3, according to this expression, according to the question, we are saying it's y. So we're going to replace that with y. And then we say minus log, so log 3 base 9 can also be, log 9 base 3 can also be written as log 3 to the power 3. Then we have a 3 there. And I also forgot one thing. If you have, let's say, y is equal to log x squared base a, so these two can drop down. This one is just the same as 2 log x base a. That's what it means. So these two can drop down and becomes a coefficient that side. So we can drop down these 3 to this part. So when you drop down that, we're going to have y minus 3 will drop down, and then we have log 3 base 3. But remember this part, I said anything that is in the format log a base a, this one is equal to 1. So this part is simply just 1. So we're going to say y minus 3 times 1. So this is just y minus 3 as the answer. Alright, so we've managed to solve this one. Let's also do that one. So this one is also just log the root of x base 3, which can also be expressed as log x to the power half, then base 3. So this one, this half can also drop down. So when we drop down that half, we're going to have half log 3, log x base 3. So log x base 3, according to the question, is just this part here, which is equal to y. So log x base 3 is equal to y. So this is just the same as half times y. That's what that means. Alright, so the other thing that we have, okay, write each answer in its simplest form here. So we have done the first one and the second one, we've done it. So the second one is this one we have said is half y, and then this one we said it's y minus 3. So let us solve the second part of the question. So the second part of the question is this one. Hence, otherwise solve 2 log x over 9 base 3 minus log root x base 3. They are saying that hence or otherwise solve this is equal to 2. So where there is this part, we can replace with y minus 3. So we say 2, then y minus 3, then minus, then while there is this expression, we can put half y, and then this is equal to 2. So let us get rid of this half by multiplying the whole equation by 2. So we're going to have 4y minus 3, then minus y is equal to 4. So I'll take this 4 to the other side of the equal sign. Or maybe let me first simplify this part. So when I simplify this part, I'm going to have 4y minus 12. When I open the brackets, I have y is equal to 4. So this 12 can go to the other side of the equal sign. And then 4y minus y will remain this side. So I have 4 plus 12. So 4 minus 4y, this is 3y is equal to 4 plus 12, this is simply just 16. 4 minus y is 3y. So we divide by 3, The value of y just becomes 16 over 3. So this is the answer. Alright, so logarithms are simple and straightforward. You don't have to be you don't have to think even much to solve such. They're simple and straightforward. There's also another question on logs. Find the exact value of x for which this equation is equal to that. So this one is straightforward. So remember what I said, if you are subtracting there, it means that you are dividing two functions. So before we even start doing that, we can first raise these two on top there. Remember I once said the log of x squared base a, this one is just the same as 2 log x base a. These two can drop down. So the same way it can drop down, it can also go up. Hence this part can also be written as log base 10, of course. Then we have x minus 2 there. Then these two, this one here, can go on top there. So we have 2 there, and then we have minus log x plus 5 is equal to 0. So when you're subtracting, means that there was a division somewhere. So we can write this as x minus 2 there, everything divided by x plus 5. And then when we do that, we say this is equal to 0. There's this squared there. Then the base here is 10. So if we want, we can write 10 or not. Base 10 can also, any logarithm that has no base, it means that it's in base 10. So let me just write it there for the sake of formation and solving. So we can convert now this expression to exponential. So let us convert this expression to exponential function. So the base will remain a base. Then what we have this side becomes a power. And then we are going to have x minus 2 there squared over x plus 5. So any number to the power 0 is simply just 1. So this is just the same as writing 10 to the power 0. This is 1 is equal to, then x minus 2, when we simplify that, it's going to give us x squared minus 4x plus 4. Everything divided by x plus 5. So when we cross multiply there, we're going to get x squared minus 4x plus 4 is equal to x plus 5. Then we take everything to one side, meaning we're going to have x squared minus 4x plus 4, then minus x minus 5 is equal to 0. So we have x squared negative 4x and negative x, we're getting negative 5x, and then 4 negative 5, we're getting negative 1 is equal to 0. So let us solve this. Let us solve this. Let us solve this equation. So we have x squared minus 5x minus 1. We have x squared minus 5x minus 1 is equal to 0. They want us to find the values of x. So the product is simply just negative 1. The sum is negative 5. The factors will be 3 and 2. Of course, 1 should be negative. Oh, rather no. It can be 3 and 2. So we find numbers that when we multiply, they'll give us negative 1. When we add, they'll give us negative 5. And these numbers, let's just solve this using the formula method. That will be the simplest way. So to solve this one using the formula method, we are going to have x is equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a, plus or minus there. So the value of x will therefore be equal to negative b, simply just be 5 plus or minus, because this negative and that will cancel. Then we have the square root of negative 5 squared, which is b, then minus 4, our a is 1, and then our c is negative 1. Then everything divided by 2a. So the value of x becomes 5 plus or minus the square root of, this will be 25. Then this negative and that negative will add, so 25 plus 4. Then everything divided by 2. So the values of x will therefore be equal to 5 plus or minus the square root of 29, everything divided by 2. So the first value of x is 5 plus the root of 29, everything divided by 2. The second value of x is 5 minus the root of 29, everything divided by 2. Alright, so this is how you solve such an equation. Right, let's quickly move on to the second part of this question, which is this one. Saying given that log of that minus that is equal to 1, where p is greater than 2 and y is less than 1, is greater than 1 rather, express y in terms of p. So remember what I said, since the bases are the same, it means that when we are subtracting there, it seems that it's just the same as dividing. So we are going to write this as log with a base p, open brackets, we have 4y plus 1 dividing 2y minus 2. This is equal to 1. So now we can change this to exponential. The base will remain the base, this side will become the power, and we say equals to whatever we have there, which is y plus 1 over 2y minus 2. So we can cross multiply. So when you do the cross multiplication here, I'm going to say p times everything this side. I'm going to have p times 2y minus 2. Then this is equal to 4y plus 1. They are asking us to express y in terms of p. Y in terms of p. So meaning we are supposed to make y the subject of the formula. So we are going to have, when you multiply through this side, we're going to have 2py minus 2y minus 2p is going to be equal to 4y plus 1. So we make all the components that have, all the terms that have y, we put them on one side, then the rest we take them on the other side. So we're going to have 2py this side minus 4y is equal to 2p plus 1. So when we factorize y this side, we are going to have 2p minus 4 is equal to 2p plus 1. So the value of y, or y in terms of p, is simply just going to be, when we divide everything by 2p minus 4, we are going to have 2p plus 1, everything divided by 2p minus 4. So this is the solution that we're going to have. This is what we are going to have as the answer there. Alright, so let's check if we have another question on logs. Okay, we have this question on logarithms, which says that show that the equation, this equation 2 log y is equal to that where x is greater than 0, y is greater than 0, may be written in the form y squared minus, is equal to k over x, where k is a constant to be found. Okay, they are saying show that this equation may be written in this form, where k is the constant to be found. Alright, so this one is straightforward. Remember what I said, if you have anything this side, it can easily go there. So we can write that equation as log y base 2 to the power 2 is equal to 5 minus log x base 2. So we can take all these, this log to the other side of the equal sign. So meaning we're going to have log y squared base 2 plus log x base 2 is equal to 5. So when you're adding two logarithms, it means that there is a multiplication. So this can also be written as xy squared, when we're multiplying this and that, base 2 of course, so we have base 2 is equal to 5. We change this to an exponential, so the base is 2 the power is what is this side. Then from there we have xy squared this side, xy squared. Then they want us to make y squared the subject. So we have y squared is equal to 2 to the power 5, that is 32. So we can write 32 over x. When you divide everything by x, so this is just 32 over x. So meaning y squared is equal to 32 over x. Or before I write the answer y squared is equal to 32 over x, let me write the way it was. So this is 2 to the power 5 over, when you divide by x this side and this side, so 2 to the power 5 is the one that is giving us 32 over x. So y squared is equal to 32 over x. So they are saying k is to be found. So we equate y squared to y squared, meaning 32 over x is equal to k over x. This x and that x can cancel, and hence the value of k is simply just equal to 32. Okay, let's solve the simultaneous equation on the second part of this question. So solving the simultaneous equation, this one, we first have to change that. Oh, it's already changed, it's there. So we have, this one is the same as that, this one. So we can just say y squared is equal to 32 over x as equation 1. And then we have this one, which is log y base x is equal to -3. We can convert this to exponential. So the base is x to the power -3 is equal to 1. So this is just the same as x. I wanted to go straight forward, but okay, this is just the same as 1 over x to the power 3 is equal to, so 1 over x to the power 3 is equal to y. So when you cross multiply, this is just the same as x to the power 3 y is equal to 1. So here we can make 1 as the subject of the formula. Of course, we can just get this one, which is already made as a subject, and then we replace it there. So this is our equation 2. Then we replace, while there is y, we put 1 over x to the power 3. So we have 1 over x to the power 3 there, squared is equal to 32 over x. So this one will just give us 1 over x to the power 6 is equal to 32 over x. So from there what we can do is we can cross multiply. So we're going to have x is equal to 32 x to the power 6. Then we take everything to one side. So when you take everything to one side, let me just erase this part. Okay, so when you take everything to one side, we're going to have x minus 32x to the power 6. X minus 32x to the power 6 is equal to 0. When you factorize, we're going to have x1 minus 32x to the power 5 is equal to 0. So here the first value of x is equal to 0. The second value of x will be found by solving this equation. So we take this one to the other side of the equal sign, or we take negative 32x to the power 5 to the other side of the equation. So we're going to have 32x to the power 5 is equal to 1. When you divide everything by 32, we are going to get the expression as x to the power 5 is equal to 1 over 32. So we find the fifth root of that, So the first value of x, or let me do this, let me write it properly. So we had 1 is equal to 32x to the power 5. Then we divide everything by 32, divide everything by 32. You are getting x to the power 5 as equal to 1 over 32. So we find the fifth root of that, the fifth root of that. So the fifth root of x to the power 2 is, the fifth root of x to the power 5 is x. Then this other side, the fifth root of 1 is 1. The fifth root of 32 is 2. Therefore, the value of x is simply just equal to 1 over 2. And then the value of y will simply be found by using any of the equation. So we can even get this one. So we can just put 2 while there is x there. So our y squared is equal to 32. While there is x, we put 2. So y squared is equal to 16. So we find the square root. We square root both sides. So when we square root both sides, this is what we're going to have. So we find the square root of both sides. So we have y squared is equal to 16. So the square root of that, square root of that, this should work with plus or minus. So meaning the value of y is simply just plus or minus 4. So we have two values of y. We have positive 4 and negative 4. So the other value of y is negative 4. Then the value of x is simply just 1 over 2. So this is the answer to this question. Let's see if we have another question. Alright, we have this question here, which is also very simple and straightforward. So this question is also very simple and straightforward. Let us see how we can solve this. So the question is find the y of which this is equal to that, giving your answer to 4 significant figures. And then this one is solved given an exact answer, the equation this. So this one is straightforward. The first one we have 4, 3y plus 2 is equal to 3 to the power 600. So for this one, what you just need to do is to introduce logs on both sides. So you cannot solve this one without using a calculator. You need to have a calculator. So you can introduce ln or log on both sides. So when I introduce log, I'm going to have log 4 to the power 3y plus 2 this side is equal to log 3 to the power 600. So I'm going to drop down this. So I'm going to have 3y plus 2 in brackets. So 3y plus 2 in brackets, and then log 4 is equal to, we have 600. When this 600 drops, I'm going to have log 3. So I'm going to divide on both sides log 4. So I'm going to have 3y plus 2 is equal to 600. And then we have log 3 over log 4. When I divide this side by log 4, even this side by log 4, I'm going to have something like this. So log 3 over log 4 on the calculator, log 3 over log 4, you can use the calculator to find that. And then if you want, they want us to find the value of y. So we can just take this to the other side of the equal sign. So when you take this to the other side of the equal sign, or according to me, since I don't have a calculator, what I can just do with this equation is that I'm going to make y the subject of the formula. So this part can be written as, let me write this first, plus 2 is equal to 600. Then this part can also be written as log 3 base 4. So log 3 base 4. So I can take back this 600 to the top there. So or if I want, I can just leave it like this. So I'll take this to the other side of the equal sign. I'm going to have 3y is equal to 600 log 3 base 4 minus 2, and then we make y the subject. Y is going to be equal to, we divide everything by 3, so y is simply just going to be equal to 600 log 3 base 4 minus 2, and everything divided by 3. So this is the answer. So if you have a calculator, you can just put this on the calculator, then you are going to find the answer. So to put this in the calculator, you can for log 3 base 4, you can just say log 3 over log 4. That's what it means. So you can also simplify this to be log 3 to the power 600 base 4 minus 2, everything divided by 3. So this is how you can simplify that. Or if you want, you can do this. You can also do this. You can divide this 3 into 600. So when you divide the 3 into 600, let me also erase this. So when you divide the 3 into 600, you're going to have y is equal to 200 log 3 base 4, then minus 2 over 3. So this is the simplified version of this logarithmic function. So you can just put this on the calculator and then find the answer correct to 4 significant figures. Alright, so let's move on to this last question there. So we have solve. The question is saying solve giving an exact answer the equation of this equation. So we have two logarithms subtracting, means that we are dividing. So we have log x plus 3 over 2x plus 4. Then everything they all have the base 2, so we can write the base 2 there is equal to 4. So we convert this to exponential. So converting this to exponential, the base is 2, the power is what is there, which is 4. Then we have this being equal to x plus 3 over 2x plus 4. So this will give us 2 to the power 4. This is 16. 2 times 2, 4 times 2, 8 times 2, 16. So we have 16 this side is equal to x plus 3 over 2x plus 4. So from there we have to cross multiply there. When we cross multiply, we're going to have 16 open brackets 2x plus 4 is equal to, and then we have x plus 3. So 16 times 2 there, we're getting 32x plus 16 times 4, that is 64, is equal to x plus 3. So we pair the like terms, we put the like terms together, we have 32x minus x is equal to 3 minus 64. So 32 minus x, we have 31, x is equal to 3 minus 64, this is negative 61. So the value of x is simply just be found by dividing everything by 31. So x will now be equal to negative 61 over 31. This is the answer. Let's find the last question there. Find the values of x for which log that plus that is equal to 5. So we're just going through the same rules in short. So we have log x base 5 plus this 6 can go on top there. We can have log 5 to the power 6, then base x is equal to 5. So we can convert one of these logarithms to the other base. Yeah, so how can we do that? Remember what I said, this one can also be written as log x over log 5. and then plus 5 to the power 6. This one is just the same as 15,625. So this is just the same as log 15,000 500 log 15,625. 625, the base x is equal to 5. Okay, let's simplify this equation. The best way or the simplest way we can solve this one is, let us do this. So let us say this one is just the same as log x over log 5, then plus this one is also just the same as log. Okay, even before we bring down the 6, let us leave it here. We have 6 there. So this one is just the same as log 5, 6 log 5 over log x is equal to 5. So we're going to say let log x be equal to y. So while there is log x, we're going to put y. So we're going to say, so this will be y over log 5 and then plus y over log 5 plus 6 log 5 over log x. We said is supposed to be y, so we put y there, is equal to 5. So here now we can find the common denominator. Yeah, so when we find the, or we can, yeah, let us find the common denominator in short. So when we find the common denominator, there we have y log 5, then there when we say log 5 into log y log 5, it's y times y, that will be y squared, plus here we're going to have 6 log 5 squared. Okay, so this one is now straightforward. Okay, so let me just show you the simplest. This one will take us time again. There are about 3 methods that we can use. Let me just show you the simplest and direct method, where we just convert this, or we convert one of these logarithms to the other log, so to the other base in short, to one base in short. So I'm going to convert this log to base 5. So when I do that, I'm going to have log x, this one is already in base 5, then I'm going to say plus, I have 6, converting that to base 5, this is just going to be log 5 base 5 over log x base 5, then this will be equal to 5. So from there, this part, remember what I said, anything that is in the form log a base a is equal to 1. So on top there I can write 1. Hence I'm going to have log x base 5 plus 6 times 1, 6 times 1 over log x base 5 is equal to 5. So just from there I can say let log x base 5 be equal to 1. So let log x base 5 be equal to 1, or rather not 1 but y. So we put y where there is log x base 5. So we're going to have y plus, then 6 over y is equal to 5. When we multiply the whole equation by y, we're going to get y squared plus 6 is equal to 5y. So we can solve the quadratic equation. So we bring everything on one side, y squared minus 5y plus 6 is equal to 0. So the product here is 6, the sum So the product is 6, the sum is negative 5. So the factors will simply just be equal to two numbers that we're going to multiply to get 6. Then when you add them, they are giving us negative 5. So this is just negative 2 and negative 3. Negative 2 and negative 3. So when we replace them there, we're going to have y squared minus 2y minus 3y then plus 6 is equal to 0. So let us factorize that quadratic equation. So factorizing that quadratic equation, we are going to get, so factorizing this quadratic equation, we're going to get y, open brackets, then y minus 2, close brackets, minus 3, open brackets, y minus 2 is equal to 0. So we're going to have y minus 2 there, then y minus 3 is equal to 0. So the value of y, or let me say, when you get each of those factors to 0, we're going to have y minus 3 is equal to 0. So meaning the values of y are 2 and the other value of y is equal to 3. So now remember that at one point we said the log of x base 5 is equal to y. So the question is not asking us to find y but x. So remember, we recall that let me just write it down. So we recall that at one point we said log x base 5 is equal to 1. So at every point where we have y here on the answers, we put log x base 5. So we say log x base 5 is equal to 2, and the other one is log x base 5 is equal to 3. So we solve these two equations. So we just convert them to exponential. So the first one here is x is equal to, the base is 2, rather the base is 5, the power is 2. And then the second one, x is equal to, the base is 5, the power is 3. Okay, so we are going to have x, the first value of x is equal to 25, then the other value of x will now be equal to 125. So these are the values of x that they wanted us to find in this question. Alright, thank you very much for watching today's tutorial. If you have any questions, feel free to contact me on any of these contacts on the screen, and don't forget to subscribe to the channel. My name is Harmtedy. Shalom, shalom.